Today we're going to be talking about arithmetic sequences, but just to get an overview of sequences in general, a sequence is a set of numbers in order that may have a relationship with each other. They also might not. So in general, we just have these numbers that are in a specific order that might have a relationship. An arithmetic sequence is a sequence where each term is found by adding or subtracting the previous term by some constant that we call d. So in this example, our value of d is 5 because we're adding 5 each time to get from one number to the next. We also have a geometric sequence where each term is found by multiplying the previous term by a constant that we call r. In this example, our constant is -3 because we're multiplying by -3 each time to get from one term to the next. Today we're just going to be focusing on arithmetic sequences though. So we have these things called recursive formulas that use the previous term in the formula, and that previous term will be written as a sub n minus 1. So we have the letter a and then a subscript with n minus 1, meaning use the term before the one you're looking for. Then there's also an explicit formula where all that you need to do is substitute in maybe a value of 1, 2, 3, or so on and so forth to find 4n. So here we need to find the first terms of each sequence. Our a sub 1, meaning the very first term in our sequence, is 1, and our formula is a sub n equal to 4 times a sub n minus 1 minus 1. So what this is saying is to find one of the terms, you're going to multiply the previous term by 4 and then subtract 1. So we know a sub 1. To find a sub 2, we're going to take 4 times a sub n minus 1. So here our n value is 2, n minus 1 is 1. So we're going to multiply by a sub 1, which we already know is 1, and then we're subtracting 1 at the end. 4 times 1 is 4, minus 1 is 3. So that's our second term in this sequence. To find a sub 3, we're still going to multiply 4 times, and now we're going to multiply by a sub 2, the number right before a sub 3. So 4 times a sub 2, which in this case is 3, minus 1. 4 times 3 is 12, minus 1 is 11. To find a sub 4, we take 4 times the previous value, which was 11, minus 1. 44 minus 1 is 43. Then for a sub 5, we need 4 times that previous value, which was 43, minus 1. 4 times 43 is 172, minus 1 is 171. And that's our fifth term, and we know that because it's got a sub 5. So we've got all 5 of the terms that we need. In number 2, it says a sub n is equal to 4 to the power of n minus 1. This one is an explicit formula because it's not based on a number that we had found before. It's based only on what place this number is in. So if we're looking for the first one, a sub 1, our value of n is 1. We're going to take 4 to the power of 1 minus 1. 1 minus 1 is 0. 4 to the 0 is 1. To find a sub 2, we need 4 to the power of 2 minus 1. 2 minus 1 is 1. 4 to the 1 is 4. For a sub 3, we need 4 to the power of 3 minus 1, which is 4 squared, which is 16. A sub 4 would be 4 to the power of 4 minus 1, which is 4 cubed, which is 64. And then for a sub 5, we need 4 to the power of 5 minus 1, 4 to the power of 4, which is 256. And those are the first 5 terms in this sequence. Finally, we have a sub 1 equals 500. We know the first term. A sub n is whatever the previous term was divided by 5. So to find a sub 2, we're going to take that previous term of 500 and divide by 5. So a sub 2 here is 100. To find a sub 3, we're taking the previous term, which is 100, divided by 5, which is 20. A sub 4 is a sub 3 over 5, 20 divided by 5 is 4. And a sub 5, the previous term was 4 over 5, which cannot be simplified, so that is our a sub 5.